Today we're reasoning through aircraft payload and range and their impact on airport design without hesitation, repetition, or deviation starting now. The payload and range capabilities of an aircraft are essential factors in airport planning and design, as they determine how far an aircraft can fly with a given load and impact runway requirements, fueling facilities, and pavement strength. Payload refers to the weight of the cargo, passengers, and baggage that an aircraft carries, while range is the maximum distance it can fly with available fuel. These two factors are interdependent. As an aircraft's range increases, its payload capacity typically decreases due to the need for additional fuel to support longer distances. Let's look at an example. Point A represents the range at maximum payload, indicating the farthest distance an aircraft can travel while carrying its full structural payload. To achieve this, the aircraft takes off at its maximum structural takeoff weight but doesn't fill its fuel tanks completely. Point B marks the maximum range achievable with full fuel tanks. But as mentioned, doing so means reducing the payload to accommodate more fuel. Point C shows the ferry range, or the maximum distance an aircraft can fly without any payload, typically for delivery purposes. At this point, the maximum amount of fuel is loaded, allowing the aircraft to travel its longest possible distance. These trade-offs have practical implications for airport infrastructure, as different routes and payload requirements dictate varying fueling needs, impacting fuel storage facilities and refueling operations. Additionally, airports must accommodate aircraft with diverse payload and range requirements, influencing the design of taxiways, aprons, and overall airfield layout. Aircraft are subject to structural limits, including maximum structural takeoff weight and maximum structural landing weight, which can impact the payload range curve. For example, if at time of landing an aircraft's weight is higher than the maximum structural landing weight, it must adjust for fuel in flight to ensure it doesn't exceed this weight upon landing. This affects not only how far an aircraft can travel but also its load distribution, influencing the design and strength requirements for airport pavements. In pavement design, approximately 5% of the aircraft's weight is assumed to rest on the nose gear, while the remaining 95% is supported by the main gears. If an aircraft has two main gears, each supports 47.5% of the total weight. For instance, the maximum takeoff weight of a Boeing 777-300ER is 351,800 kilos. Given that, each main gear supports around 167,000 kilos. One 777 main gear has 6 tires, meaning each tire supports an equal fraction of the load at 27,850 kilos. The maximum structural takeoff weights, landing gear configurations, and loading distributions are critical for designing airport pavements to handle these loads safely. In passenger aircraft, the payload is usually less than the maximum structural payload due to space limitations, as each passenger with baggage is typically counted as a 200-pound unit. This affects how weight is distributed within the aircraft, impacting center of gravity considerations, which in turn influence how pavement loads are distributed across an aircraft's landing gear. For airport planners, understanding the payload range characteristics of the aircraft expected to operate at an airport is crucial for determining required runway lengths and operational capacity. Since higher payloads generally require more fuel, runway lengths must account for the increased weight at takeoff, which affects acceleration and takeoff distance requirements. Conversely, longer range necessitates adequate fuel storage and refueling infrastructure, particularly for airports that handle long-haul flights. Planners must also account for various weather conditions, as headwinds or tailwinds can alter the payload range dynamics, impacting fuel efficiency and travel distances. In conclusion, the payload and range capabilities of aircraft have a direct impact on airport design, dictating requirements for runway length, fuel storage, and pavement strength. Airport planners use payload versus range data to anticipate aircraft weight characteristics, which helps them to design infrastructure that can support efficient and safe operations across various flight stages and destinations.
If you like this video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more aviation content.